Okay, so this lesson today is writing the equations of a tangent line. As I've been stating all along, you're learning all the mechanics to derivatives, okay? So we know derivative itself is representing instantaneous rate of change. And we know a derivative, geometrically, is the slope of the tangent line. So what we're doing today is finding how to write the equation of that tangent line at a specific x value, which will incorporate the slope. This is really important in the future because we will use tangent lines to estimate values, and you will have to be able to create the equation of a tangent line to illustrate that value. Okay, so anytime I say write the equation of a line, just in general, just the equation of a line, from geometry, you should remember the point slope form. Okay, you probably also know from algebra the slope intercept form. That was y equals mx plus b. We're not going to really use that. From now on, anytime we're writing the equation of a line, and I know you use this often in geometry, you're going to use the point slope form. That requires you knowing a point, so an x1 and a y1, an x value and a y value, that gets plugged in here. And you will also need the slope, which is your m. So these are the three pieces of that equation that you sub in for. This is my m. Well, the slope of a tangent line, we know that is the derivative. And we just finished learning about all different ways to calculate the derivative. Okay, so hopefully you printed out the worksheet that was posted online, or just jot down the 4 examples. I'm going to try to get through them all in this one video. So number 1, mine isn't the printed out version, I just wrote it, but yours is the same. It's the same exact problem. Write the equation of the tangent line to the curve y equals 5x squared plus 6x plus 2. So as soon as they say write the equation of a tangent line, I go, okay, I need to use y minus y1 equals m times x minus x1. That's the equation I definitely have to use to find that equation. And the two things I need is a point and a slope. And once I have those two values, well, then I can go ahead and plug in. So they're saying at x equals 1. So I want to know the point when x is 1. So I already know part of the point. I need to find the y value. How do you find the y value? You take the original function and you're going to plug in the x value that they mentioned. So 5 times 1 squared minus 6 times 1 plus 2. And then I get y is equal to, you do exponents first, 1 squared is 1, times 5 is 5, minus 6 plus 2. Well, then y is equal to, that gives me a 1, because 5 minus 6 is negative 1, plus 2 is 1. So the point now is 1 comma 1. Check, I have my point. Now the only other thing that I need to find is my slope. Because this is the slope of the tangent line, well, I know that my slope is dy dx. So off to the side here, I'm going to take y equals 5x squared minus 6x plus 2. And I'm going to find the derivative. So this, I will use the power rule to find that derivative. Dy dx is equal to 10x minus 6. But here's the problem. A lot of kids try to put this as your slope. A slope is a value. This derivative is the rule to find the slope at any x value. If I wanted to know at negative 1, when x is negative 1, what the slope is of that tangent line, I'd plug it in. But here, I want to know the slope of the tangent line when x is equal to 1. So I have to evaluate it. That's really important. You want to evaluate the derivative at the x value that they gave me, which was 1. so dy dx is equal to 10 minus 6, so dy dx is equal to 4. And that's my slope. Okay, so now that I have my slope and my point, it's now going back to stuff that you already know. I need to sub in the y1, the m, and the x1. So I just go ahead and write y minus 1 is equal to 4x minus 1. And you can leave this like this. This is the equation of the tangent line. Or you can clean it up, distributing that 4 to get 4x minus 4, adding 1, y equals 4x minus 3. So both of these are the equations of the tangent line. I'm going to tell you right now, I wouldn't go further than this unless they ask me in slope-intercept form. So what is this telling me? That if I create this right here, when x is 1, the equation of this line here is y equals 4x minus 3. Okay, that's it. Let's try a couple of more. The next one, write the equation of a tangent line at x equals 1 for the curve y equals 2x plus 1 to the 4th power. Okay, as soon as I see write the equation of a tangent line, I tell myself, all right, I need to find a point, and I like to find the point first, and then I got to find the slope. Well, the point is just found by taking the original function, y equals, this is me finding the point, 2 x plus 1 raised to the 4th power, and I just plug in the x value that they told me when x is 1, and I go y is equal to 2 times 1 is 2, plus 1 is 3, 3 to the 4th, so y is equal to 81. So my point is 1 comma 81. Perfect. So now it's just up to me to find my slope. My slope is taking the derivative. So I go, okay, y is equal to 2x plus 1 raised to the 4th. Well, to take the derivative of this, I have to use the chain rule. So here I go dy dx is equal to that 4 comes in front, so it's 4. You rewrite what's inside, drop this down by 1, and then finish by taking the derivative of the inside. Then you could clean it up to dy dx is equal to 8, 2x plus 1 to the 3rd power. But don't you leave your answer like this. I want to evaluate this slope, this derivative, when x equals 1. So I find 8, 2, you plug in that 1 plus 1 cubed, and then I get 2 times 1 plus 1 is 3, 3 cubed is 27, times 8, and then dy dx is 216. Okay, so my slope at x equals 1 is 216. So now that I know my point, which is right here, and I now know my slope m is 216, and yes, you can get these crazy numbers. Now you just plug in y minus y1 equals m times x minus x1. Y minus 81 is equal to 216 x minus 1. And I would leave my answer like this. This is perfectly fine. Okay, the next one. Number 3. All right, here, same thing, writing the equation of a tangent line to the curve, and I need to find it when x is equal to 4. So I know that I need to find my point, and I know the x value of that point, but I'm still figuring out the y, and I need to find the slope, and I know I'm going to do that by taking the derivative of x cubed, the square root of x cubed, plus 5x minus 6. So here, to find the point, you're going to plug it into the equation. So y equals the square root of 4 cubed plus 5 times 4 minus 6. So 4 cubed is 64, and the square root of 64, this turns into 20, minus 6. Square root of 64 is 8, plus 20, minus 6. So you get 28 minus 6, you get 22. So the y value to my point is 22. So now I'm almost done. I just need to find the derivative, but I definitely can't take the derivative in this form. I need to rewrite this. Power over root, x to the 3/2 plus 5x minus 6. So when I take the derivative of this becomes dy dx is equal to the 3/2 comes in front, and I drop this by a whole, so I get 1/2 plus 5. And now remember, the extra pieces, you need to evaluate this, evaluate the slope at x equals 4. So at dy dx, I'm going to take my 3/2, and now x to the 1/2 is the same thing as the square root, and I'm plugging in the 4 plus 5. Well, the square root of 4, that turns into 2 times 3/2 plus 5. And as you see, this is just algebra now, right? This becomes, these cross out, I get 3 plus 5, and I get 8 to be my slope. So now, once I know that my slope is 8, now I just go ahead and plug into my point slope formula. And when I plug that in, it becomes y minus 22 is equal to 8 times x minus 4. Okay, perfect. We got one last one to do, and I think we are okay on time. All right, so here it says write the equation of a tangent line to this curve at x equals 2. So I know my point, the x value is 2, and I'm going to find the y value by just plugging it in. The big thing is knowing that you're not touching the equation, you're just subbing in the x value, and I'm subbing in 2. And when I do that, I get 2 squared, which is 4, over 3 times 2 is 6 minus 1 is 5. So I get 4/5 as my y value. Now, to take the derivative of this, it looks a little tricky, you have to use the quotient rule. So y equals x squared over 3x minus 1. Now guys, you can make your key. You can make this f of x, this be g of x, find what f prime of x and g prime of x is, and do the quotient rule, which is the derivative of the first times the second minus the derivative of the second times the first. I'm going to do it without using the key, but please feel free to use the key. So here, when I do the derivative of the first, it's 2x times the second, 3x minus 1. That whole thing is the first part minus the derivative of the second, which is just 3, times the first, which is x squared, all over the second, which is 3x minus 1 squared. All right, so I did the quotient rule. So here, I can clean it up, and sometimes you don't have to because you're evaluating this, but if this one's easy enough to clean up, I get 6x squared minus 2x minus 3x squared. And when you clean that up, you just get 3x squared minus 2x, and it's all over 3x minus 1 squared. So your derivative is this right here. So now you just have to sub in the x value. So 3x squared minus 2x all over 3x minus 1, that whole thing squared. Well, my x value was 2. So I plug in 2 anywhere I saw those parentheses, and this becomes 2 squared, which is 4, times 3 gives me 12 minus 4, which is just 8. And down here, I get 3 times 2, which is 6, minus 1, which is 5 squared over 25. All right, so this is my slope.